Hey Year 12 students, welcome to Maths Methods. These videos are going to be used to go through some of our notes and examples for what we're covering in transition. So this is the first one and it goes through exercise 1A. So let's get stuck into it. 1A is all about set notation and sets of numbers. So a lot of just symbols and language to know here. It's probably not the most exciting maths you're going to do, but it's important that we understand when we see certain symbols and certain phrases what they actually mean. So let's run through it. A set is a collection of things, which typically is numbers, but it doesn't actually have to be. We often write the elements or numbers or things inside of a set within these sort of squiggly looking brackets. And we also use notation to indicate when something belongs to a set, or maybe when two sets overlap, or if something's excluded for a set, and so on. So this list of symbols here is a good one to just come back to if you ever see these symbols and forget what they mean. So we have the element of symbol, and then same symbol with a line through it means not an element of. We have is a subset of, which you can kind of read as like is contained within. That's like if one thing is contained within another, we call it a subset. We have the intersection symbol, which informally just means and the union symbol, which informally means or. And little sort of forward slash, backslash, I think that's a backslash, means excluding. So that's when we want to use notation to actually leave something out of a set. So some questions here about set A, which has the elements 3, 5, 8, 9, and set B, which has the elements 1, 2, 3, 4, 5. First question, a couple of yes or no ones actually. Is 5 an element of B? Well, is the number 5 part of the set B? Yes, it is. Is A a subset of B, which means are all the elements of A also contained within B? And no, they're not. Some of them are, but for example, 8 and 9 are not part of B, so that's a no. Is this smaller set 4, 5 a subset of B? Well, yes it is, because both 4 and 5 are inside the set B, so yes. And then we're being asked to write down the following sets. So A intersection B means write down the elements that are part of both A and B. So that would equal, what numbers are part of both A and B? 3 and 5. All right, now you can see those brackets, they're not going to be perfect, but just make sure they've got a squiggle in them and they don't look like normal brackets. A union B is anything that's part of A or B or both. So we're going to just list them in order. We've got 1, 2, 3, 4, 5 from set B. But also from set A we have elements 8 and 9. And then this set here means A excluding B. So start with the set A, but exclude anything that's part of B. So in other words, take the set 3, 5, 8, 9, but take out the elements 3 and 5, because we're taking out anything that was within B, which would leave us with the set 8, 9. Some other sets of numbers that kind of get their own special symbols. Natural numbers, we often use the capital N to represent natural numbers. These are like the counting numbers, so they're positive whole numbers starting from 1. Integers, which are used a lot in methods, capital Z basically means all numbers, all whole numbers I should say, positive, negative, and 0. 0 is an integer as well. You won't see this one as often, but if you see the capital Q, it means rational numbers, and that just means all numbers that can be written as a fraction of two integers, so where the numerator and denominator are both integers. So 2/3 is a rational number, 7 over 12 is a rational number, and so on. Real numbers, capital R, just means all rational or irrational numbers. So, pi, surds, e, any kind of number, whether it's rational or irrational, as long as it's a real number and actually exists. So real numbers basically just means any type of number we would use in maths methods, positive, negative, or 0. This little note here is just sort of for your information, but all natural numbers are integers, all integers are rational, and all rational numbers are real. So you kind of have this N is a subset of Z, which is a subset of Q, which is a subset of R. And it's worth knowing as well that often when we're using R for real numbers, you might see some of these, this sort of notation, R excluding 0, which might be a situation where you want all real numbers but not 0. R plus, and likewise if you saw something like Z plus, would just mean that set of real numbers but only the positive ones. And then R minus would mean the opposite, that set of numbers but only the negative ones. Some other lovely notation that we need to remember from year 11, interval notation. So we can use notation to represent sets of numbers that are kind of like starting from one point and ending at another point. Just remember here, and I know this picture's probably not coming up that well on the video, but we have to be really careful about whether we want to include endpoints or not. So for example, if you want to represent the set of numbers between 1 and 2, but not including 1 or 2, we use round brackets. If you say wanted to include the 1 but not the 2, you'd use a square bracket on the 1 and a round bracket on the 2. If you wanted to have an interval that was from 1 to 2, including both of them, they would both have square brackets. We can also have intervals that go up to positive infinity or down to negative infinity. Infinity will always have a round bracket on it. So for example, this one here is 1 to infinity, including 1. But you notice that the interval is written as square bracket 1 to infinity with a round bracket. And of course, a couple of examples here that go down to negative infinity as well. We always give our intervals from left to right. So you list the lower number first and then the upper number. So for example, negative infinity up to 2. All right, let's try a couple of our own. So example 2, represent the following number sets on a number line. You've got the interval from -2 included to 3 excluded. So that means we're going to draw a solid closed circle at -2 on our number line, open circle at 3. Would have been nice if I drew that straight, but hopefully you get the idea. So that's that interval on a number line. This one here looks a bit different. It's just asking us to write down x such that x is greater than 1, but less than or equal to 4. So that just means that our interval starts at 1 with an open circle because it's not included, and goes up to 4 with a closed circle because 4 is included in that interval. R plus just means all positive real numbers, but it doesn't include 0. 0 is not a positive number, so this would look like an open circle above 0 and then a line going to the right, which we can just put an arrow at the end to say that keeps going and going. This one's an interesting one. This one's an intersection between two intervals, so it could help to actually write out both intervals separately first and then work out where the intersection is. So we've got, I'm going to do the two separate ones I'll do below. 0 to 2 would look something like that, and they're both closed circles because they both had square brackets. 1 to 5 with open circles would look something like this. So where they intersect, where both of these exist, well, the lowest value we have is 1, where they both exist, but that's not included there, so our overall interval will actually start at 1 with an open circle, and then they both go up to 2, and both of them include 2. So we'd have a solid circle at 2, and we get that interval there. So that interval there is sort of our final answer of the intersection of these two. And finally, R plus union 0. I guess this is a good one to compare to example C. It's almost identical, but this one now will include 0 because this is saying all positive real numbers or 0. So closed circle above 0, and then a line saying those numbers will go up and up to positive infinity. And that's exercise 1A. So get stuck into your work, and regardless of who your teacher is, make sure you reach out and ask any questions if you need a hand with it.